turn to the last page in your packet. Okay. Yesterday we filled all this stuff in. Did we get it all? Or the day before we filled all this in? Did we finish? Can't remember. Did y'all finish that page where it was like Gabrielle's budget? Yeah. Okay. So you're going to answer these questions. Okay. So go ahead and take a moment, answer questions 1 through 5. Okay. Just answer questions 1 through 5. So you're using Gabrielle's budget. If you didn't fill that in or you weren't here when we did it, just ask a neighbor for it. Okay. Good. Okay. Go ahead and get started on that. So, what is the difference between Gabrielle's planned expenses and her actual expenses? Okay. So, what does deficit mean for the people who weren't here yesterday? She's in debt, right? So, $650 and she was in a deficit. Okay. Surplus means that she would have more money. Deficit means that she owes money, right? Okay. And what areas did she have a deficit? Okay, so rent, car payment, food, gas, parking, repairs, miscellaneous, because there was that speeding ticket, right? Clothing, entertainment. Homegirl did not care this month, apparently, right? And even personal items, because she didn't account for the birthday, right? In what areas did she have a surplus? Savings. She didn't save. Well, she had a surplus in that savings, right? Like there wasn't a deficit in that column. Yeah. Okay. How much did she spend for the use of her car this month? Okay, so how'd you get that? How much is her car payment? 175. And then what else? What about car insurance? Look at your columns for your what actually happened. 295. Okay, what else goes with cars? What about gas, oil? 60. And then say it again. All right, parking and tolls, that's 34. And then what's that last one? She had a speeding ticket, right? How much was that? So when we take into account those speeding tickets, we get 784. So just on driving alone, she spent 784. Is it 230? Okay, so when you total that up, 175 plus 295 plus 60 plus 34 plus 230, 794. My apologies. Good? Okay, so it should be 220. Sorry.
But it's also 2.
No, because that's not going to be on her car. That's just on her being a not so smart driver. So on her car alone, she spent 784. With the speeding tickets, she added an extra 230. So 220 was the repairs, right? Okay. Now, how much money did she have at the end of the month to put into savings? None. Homegirl was in a deficit, right? Okay. So 0. Everybody understand? Questions? Okay. It seems like it's simple, but when you actually start like life starts happening, you start making all these little payments, all those little like quick trip runs, you know, eating at McDonald's, going to Zaxby's, going to Chick-fil-A, all of that totals up. Best way to kind of figure out how much you spend on stuff is to get a credit card. Maybe, you know, put your food on that credit card only And then at the end of the month, pay it off and look at how much is it total. Yeah. And then you can kind of dwindle it down from there. Do you eat out a lot? Do you need to not be eating out a lot? Okay. And it kind of depends on your life. Like if you're constantly working, you don't have time to cook. Okay, fine, but you're going to pay for it. Yeah. Because how much is a Zaxby's meal? Okay, let's do Zach snack meal. How much is that? Right. It used to be like 5, 6 back in the day. Okay. Now it's a little bit more expensive. Like you can't walk out without spending like $10 on a meal, right? That's already $30 a day just to eat. Yeah. Question? Anybody question? Okay, cool. All right, go ahead and flip in your packet to the page for 1.4. 1.4. What's up? Okay, so it says I can interpret slope in context. Refresher from 6th grade. Yes. Slope is rise over run. Okay. So how you calculate it is you go up however many units and you go over however many units, right? Another way you've seen this is y2 minus y1 over x2 minus x1. Oh, sorry. I didn't change the screen. Boom. There you go. So it's rise over run. So you go up however many units, over however many units. And y2 minus y1 over x2 minus x1. When I ask you for the formula for slope, don't you dare tell me y equals mx plus b, because we might have to scrap, okay? I'm letting you know now, that is the formula you're going to tell me, okay? Don't you say it. Don't you do it. Don't you do it, okay? I spent a whole year last year with the freshmen. Don't do it, okay? Another way you might see this is change in y over change in x. That delta means change, so subtraction, okay? I'm just trying to throw something at you so you remember. Do we remember slope? Yes. Okay, kind of, sort of. Okay, hopefully today we won't have any more problems, okay? Linear equations. What does a linear equation look like? If I say linear, it is a what? It is a line, okay? Linear equation is a line. Okay, so slope is the rate at which a function changes. Slope is change in y divided by change in x. So just like what we just talked about. The units for slope are y value per, what did we learn about yesterday with per? What does that mean? Divide y divided by x. Everybody okay? Okay. So what are the units for slope of the line? So looking at this graph right here, what are the units for the slope of the line? What is our y value measured in? Miles. Okay. Over, what's our x values measured in? Hours. So we say miles per hour. Let me see where I got that from. I took my y axis over my x-axis. Okay, so my visual learners, y per x. Okay. All right. What is the slope of this line? Okay. Don't write anything down. I want you to watch. Okay. What is the slope of this line? So when you do slope of the line, what I want you to do is start at a point on the graph. Okay. You need to find another point that is easily identifiable on the graph. So do you notice how I picked the y-intercept? And I picked one that was on the line. I didn't pick something that was in between. I can't guesstimate the slope. It has to be exact points. Okay. Now, how much did I go up? So from 10 to 25, how much is that? 15. Okay. So I'm going to write 15 right here. How much did I go over? 1. Okay. We talked about how slope is y over x. So 15 over 1. 15 divided by 1. What is 15 divided by 1? 15. And we're going to say miles per hour. Okay, so when you're given a graph, draw the slope. Okay? Don't get slope wrong. You did it in 6th grade. Okay. What does the y-intercept represent? Okay, so y-intercept's right here. Yes, baby. Okay, so the initial miles, okay, or distance at time 0. We're going to say initial miles as well. Okay, looking at this line, what can you say about the speed from 0 to 3 hours? It's increasing at what pace? It's increasing for 15 miles per hour. It's going at a, go ahead.
Constantly.
Yes, there it is. Okay, so it is a constant speed of 15 miles per hour. Now, most of y'all drive, if not all of you. Do you drive at a constant speed?
No.
Okay, I got road rage. It's bad. It's a whole thing. So like I'm that person in the left lane that's yelling at you to get over. Like that's me. Okay. It's fine. It's fine. I only got one speeding ticket when I was like 19. It's fine. Okay. So don't speed, kids. So with that being said, we don't really move at a constant rate when we're driving. Okay. So that really wouldn't work for us like driving wise. What might it work for? When you're running, I don't know about y'all. I'm a terrible runner. I don't run at a constant rate. I'm like sprint and walk. Sprint, walk. Yeah. But maybe running. What else? Okay. Would that be at a constant rate? Maybe. Okay, cool. All right, so if change is constant, the shape of the graph is going to be a straight line. Okay, don't be like my freshman last year when I asked the shape of a linear function, please, for the love of all things good and holy, put like line. It looks like a line, a linear line. Okay, this is called a linear function. Y'all notice how I have PTSD from last year and how my kids didn't understand linear functions? Don't be like them. Okay. All right, so if you pay $15 per month for a streaming service, the rate at which your cost increases is going to be $15 every month. So the slope is $15 per month. Okay, so coming down here, I'll write it up on the board so you can see it. All right, so your fill-ins are $15 every month. So slope is going to be $15 per month. All right, we already talked about how slope is y per x. So the y value is in dollars and the x is in months. So this equation is going to be y equals 15x. How much is Netflix now?
And that's not even real.
Apparently there's like a premium, there's a Netflix premium. Yeah. Like
I'm not cool enough for that.
Apparently it's like you can buy Netflix premium and still have that.
No.
I would fight them.
Oh, like they, I guess it's like some sort of subscription where you buy a premium, but you still have ads. So you have
Yeah,
to
it's
premium.
Yikes.
That is crazy. Never got
I'm going to continue using my parents. So I'm not even going to lie. I think I bought my own like Disney Plus, but like Netflix, I'm not paying for. Yeah. Well, I've got the 7 and the 4-year-old. So like, that's fair. So, all right. Using the equation, how much will you pay over 5 months? So how do we figure that out? 15 times 5. What is that going to give me? Use your calculator. What is it? 75. You're going to pay $75 for 5 months just to watch some random shows. don't know. Netflix be okay. Y'all watch Love is Blind? Yeah. Yeah. Jimmy. Good Lord. He messed up.
Yeah. Oh, I know. There you go.
Oh,
You saw
God.
that.
All right. Example 1, in the early 2000s, phone companies would charge per text message. That actually was a thing. We would charge per text message. Okay. In 2005, Katie's phone plan cost $39 each month, plus 10 cents for every text message she sends or receives. I'll be honest, that's why back in the day, we used to be so concise with what we said, because it was like, if you sent more than one text, 10 cents every time. Per text message. Like, think about it. If you sent like 3, that's 30 cents. Yep. Okay, so write a linear function that represents Katie's monthly phone bill in dollars as a function of the number of texts she sends or receives. Okay, so we're doing it for a monthly phone bill, the number of text messages she sends. So let's say Katie don't text that much and she didn't send any text messages. How much is it going to cost her? Look again. Read it again. Oh, $39. Off the bat, $39. Let's say she called everybody because she didn't want to text anybody. $39. Okay. That's our which intercept is that? Y or X? Y intercept, because that's our initial value. Now, each time that she sent a text message, it was going to be 10 cents per text message. The way we write cents, okay, is we're going to say 0.10. So we're going to say 0.10, and we're going to multiply it times X. X is going to represent our text messages. So X represents the messages that she sends. About how many texts do you think you send or receive in a day? 10? 10?
There was a lot of business.
30? Okay. Let's do, okay, so personal evaluation, whatever your number is, go ahead and write that down in this little thing. I think I sent probably like 120, but I talked to a lot of people. Okay, you gotta remember, I'm a coach. I got a boyfriend. I got my mom, got all that. So like, you gotta think about, like, I interact with a lot of people. So if I were to send 120 text messages, how many or how much would this be in a 30-day month? How many would be this? How many would this be in a 30-day month? How many text messages would I send total? 120 times 30. Tell me what that is. 120 times 30. Say it again. 3,600. So in a month, I'm sending 3,600 text messages. I'm going to have to count it now. Now I'm interested. Okay. Using the equation, what would my phone bill be in 2005? So what would we do? Okay. So 0.1 times 3,600 plus 39. Somebody type that. I need you to practice typing this into your calculator. So if you don't have a calculator nearby, get one. I need you to practice typing it in, because if y'all make a mistake on this kind of stuff, it's gonna be bad news bears. Tell me what you get. 399. In 2005, I would spend $399 for 1 month if I sent that many text messages. It was expensive. We didn't text that much. Like, you wouldn't send LOL. Yeah. You just wouldn't laugh at whatever somebody said. Just silence. Yeah. It's fascinating that y'all don't live in that kind of time. That's crazy. All right. So according to the smoking status and BMI study, clients aged 20 or older with a higher BMI paid higher premiums on average. So we're back to the BMI. Remind me what BMI was? Body mass index. And remember, we got to convert it to kilograms, and we've got to convert it to meters. And we use the formula. And yes, it will be on your formula sheet. If you missed that yesterday, remember, your YouTube video is posted on your your Google Classroom. Okay. Example 2, Brad is 68 inches tall and weighs 210 pounds. Okay, so what is the first thing that we need to do in order to calculate his BMI? Convert. Okay, so go ahead and take a moment. I want you to convert Brad from inches to meters and pounds to kilograms. Remember, 1 kilogram is how much? 2.2 pounds. And 1 meter is equal to how many inches? It's 39.4 inches. Okay, take a moment, do those conversions. And then just a reminder that BMI formula was your kilograms divided by meters squared. Okay, take a moment, calculate that. All right, so I saw a lot of us got the 1.73, and then we got the 95.45. Okay, now when you calculate the BMI, remember you're going to put your kilograms over your meters squared. Okay, so you should have gotten 31.89 or 31.9. Okay, what would that put him at his premium up here? So obviously Brad is a male. Okay, so looking over here, 30 and above, he would be at 187 per month. So how much will he spend by the end of each month? So the first month, how much is he going to spend? 187. Now after 3 months, hey baby, come on in. After 3 months, how much is he going to spend? So we would take 187 and do what? Multiply it times 3? All right. Can you fill in the rest of this table? Go ahead and take a moment. All right. So you should have gotten 1,100, bless you, 22, and then 1,683, and then 2,244. At the end of 1 year, he just spent $2,200 on health insurance. Like, let that set in just a second. Like, that's a lot of money, right? Okay. That's a lot. Lose weight. That's an option. Okay. But they're calculating with BMI. What did we learn about BMI versus waist to height ratio? Right. Because like he could have like a lot of muscle mass, right? But he's being considered obese, right? Okay. On the next one, it says use the table to calculate his yearly cost, which we already did, which is 2,244. Okay. All right, so now we're going to write and graph a linear equation that represents the relationship between months and total premium cost. Okay. Anybody ready to graph? I know it's been a while. Okay. First thing, this is your x-axis. This is your y-axis. This is your x. This is your y. Okay. It wants us to write a linear equation that represents the relationship between months and premium cost. Okay. So our x value is going to be months. And our y values are going to be premium cost. And we always want to make sure that we're putting it in our units. So this would be dollars. Okay, so for Brad, how much does it cost each month? Okay, so it's 187. That's going to be what part of our equation? What is that called? Not the y-intercept. It's called the slope, right? So 187 times x. Okay. At month 0, how much is he spending? $0. So our y-intercept is going to be 0. Okay, he hasn't bought health insurance yet, right? At month 0, no health insurance. For the first month, it's 187, right? So that's roughly right here. For the third month from our table, we can see 561, which is about here. For the 6th month, which we saw from our table, it was 1,222, which is about here. Okay. From our 9th month, we got 1,680 something. Right there. And from our 12th month, we have 2,224. Now, to get the most accurate depiction, we want to probably find these other points, but we can go ahead and connect those dots. How many dots do we need in order to draw a line? For a graph, 3, right? Okay, so 3 is like the magic number for being able to draw a graph. I'm so sorry I can't draw a straight line on this thing. What does the slope represent in this? What does the slope represent in this? What does the slope represent? What is it? Okay, cost per month. Okay, so yeah, you can call this premium cost if you want. You okay on that? Okay, go and do me a favor, take out your laptop real quick. Yay.
So we want to introduce just another way of calculating the new price if there's a percentage increase or decrease. So in this case, we've got an original price of 90. There's a 7.9% tax to add on, and you need to calculate the code. So far we've been saying, okay, calculate the percentage increase, right? This is an individual calculation. So that would be 19 times 0.079. Get a number, yeah? Then add that to the 19, and you get your new price. Right? You can do that in one step by, instead of multiplying by 0.079, calculating that and adding on to the original, just multiply by 1.079 in one shot. So the 1 essentially is your original price, right? It's including that as part of the calculation. You'll get the same answer. So how would that, yeah, I write that down. So that would be new price, new equals 9.
Okay, what it keeps saying on Delta Math, it's probably something like this. Right? Something like that. That was simple interest that you learned in 9th grade. That's actually what you learned. You learned appreciation and depreciation. Yeah? Okay, so that's what he's talking about. Now, if you have something that's going down, like for instance, this one, it says it has gone down 17%. Okay, then you're going to do that 1 minus that he was talking about. So instead of 1 plus, you'll do 1 minus. So what's the original price of this one up on the board? Okay, so this is my original. Okay, it says that it's gone down, so we're going to subtract. We want to make sure that we turn that percent to a decimal, so that's going to be 0.17. And then how much is the stock worth now to the nearest cent? So we would do 125 and 1 minus 0.17. Okay, and we would just type that directly into our calculator. Okay, yep. A level 3 question? Yes. Okay, everybody good on level 1? Nothing crazy? Okay. And that was just a quick way to kind of go through those. Are we talking about percent more or less, this one? Okay, so on this one, it says when a number is decreased by 28%, the result is 60. What is the original number to the nearest 10th? Okay, so if we were going to work this out, we would take our original and multiply it times our percent, right? Or percent in decimal. That would give me the total that it was decreased by, right? But we don't know the original. We know the final answer, which what he was talking about was you can use that formula where we have 1 minus our percent. What's our percent? 0.28%. We know that it's going to be equal to 60, and we're going to find what the initial is, or our original price. Okay, so what's 1 minus 0.28?
$1.17.
Okay, and if I'm trying to find the original, what am I going to do next? Not subtract, divide. Okay, so if I divide by 0.72 on both sides, then that's going to give me 83.3. That makes sense? That was like question number 4 on that worksheet that we did yesterday. Kind of similar. So he's showing you a kind of like a simpler form of that formula. Are we okay? Or are we confused? Okay. All right. So go ahead and take a little bit of time. Go ahead and work through those problems.